Hello and welcome. Welcome to one of our regular sessions where we ask past winners of best papers from our annual systems engineering conferences to come and present their papers so we can record them and store them online and make them available for everybody. Can I ask if you've got any questions, can you please just type them into the chat facility? And then at the end of the presentation, I will then present the questions to our speaker. Okay. Our speaker today is Vicky Anderson. I first met Vicky, I was trying to look this up, so I looked it up on LinkedIn. It was way back in 2007 when Vicky used to work in the defense industry, so way too long ago for us to start calculating how old we all are. But it was a long time ago. I've seen her on a fairly regular basis ever since, every couple of years. And it was back in 2019 when she presented this paper at the annual Systems Engineering Conference in Leeds. And it won Best Paper, it won Best Newcomer, and I believe it won Best Presentation as well. So basically, Vicky really cleaned up on all the awards on that year. So it was an excellent paper. She's going to present the paper as, bear in mind, it was written 4 years ago, as it was presented 4 years ago, so you can get the authentic experience, if you like. The title of the paper is The Open Source Satellite Program Using Systems Thinking and MBSE to Align the Team and Explore the Problem. So I'm slightly biased because that's two of my favorite things in one paper. So I'm really looking forward to hearing this again, Vicky. I saw it the first time. And so without further ado, I'll hand over to you, Vicky, and it's over to you. Thank you.
Lovely. Thank you for the introduction, John. Let me just share the presentation. So hopefully...
Yep, that's up now, Vicky. You're good to go.
Perfect. Lovely. Right, so yes, so as John gave me a lovely introduction there. So my name is Vicky Anderson, and I work for a company called KISS Space, and we're based in Farnborough in Hampshire. And it's actually really nice to revisit this presentation, as John said, I gave way back in 2019. So it's been nice to kind of dust it off and have a look at where things were at that point. And what we're going to talk about today is I'm going to cover our open source satellite program and how we were using and leveraging systems thinking and model-based system engineering to our advantage as part of that. And the intent is to cover the material that's shown here in the contents slide. I'm going to start with a very brief overview of the company that I work for, because there's probably a few of you who kind of went, KISP, who are they? You know, heard of those. So I want to give you a bit of a background there. And then I'm going to run through the context as to what the open source satellite program is and why it is at KISP we think it's necessary. And then once I kind of set the context for the program, I'm then going to explore what we are looking at doing with systems thinking and model-based system engineering, and how we're going to apply that to the open source satellite and what activities have been undertaken using, so far. And then finally, I'm going to wrap up what we found. So what we found whilst going through this process and what the next steps would be. And at the end, we can go through kind of contact details and the like, if anyone's interested and wants to talk about it more. So KISS Space is actually an operating entity of a company called KISP Limited, and KISP was founded back in 2016 by Dr. John Paffett, and our parent company KISP kind of covers a whole range of sectors, so electronics, telecommunications and space. And I specifically work within KISS Space, which, as the name suggests, targets the space sector, and this is where the open source satellite program is hosted. Now, as a company, we work with customers right across the value chain and across the project lifecycle. And we have this slightly cheesy, but I do love it, and it is at the heart of everything we do. Our tagline is turning ideas into reality. So some examples of how we're doing that, how we're helping people with that is we do a lot of work where people come and go, hey, I want to have this idea and I want to try and get this data from space, but I'm not quite sure how to go about it. We help them develop their business cases and go on and actually select, the best solution to get them the information that they need. So we go right from sort of concept development right through to kind of manufacturing operations. We've been helping another client who has manufacturing capability in the UK, but has never done manufacturing for space or testing for space. We've been helping them set up facilities and actually going through the process of taking a satellite from the bits, putting it together and actually getting it launched and in orbit. Our team has, I mean, decades of industry knowledge and across lots of different aspects, so engineering, programmatic, strategic, management, you name it, someone in our company has done it, and they've done it at a wide range of different organisations. A quick bit of background for myself. So I started life as an electronics engineer in the defence domain before taking those skills into the space sector. I then went back to the defence sector to take an official systems engineering role. And whilst I was there, I did a part-time postgrad diploma in systems engineering at the University of Cranfield out of Shrivenham. And then I took that qualification and the skills I developed, moved back into the space industry, and have taken the role that I'm doing today, and hence why I'm talking to you guys today as well. So as a company, one of our key things is we really want to develop and build the competence of the clients that we work with. Our boss really dislikes the term consultancy and consultants, because that implies you come in, you do something, you leave, and you kind of, you leave the product that you give, but you maybe don't do some of the value add, some of that kind of knowledge sharing and training. And so we're always looking as an entity how we can add value. And this overarching kind of company ethos and mentality feeds into our vision and mission relating to the open source satellite. So we really want to make space more affordable and accessible than it is today. And we really believe that, this is really important, because it's only by making space and space-enabled systems more affordable and accessible that actually, we better realise the true potential of space. So we want to better stimulate new applications and services. But a key point for us is we want this to be done in a responsible and sustainable way. We don't want to be contributing to kind of the space debris and those kind of issues which can be seen in the space environment. So why do we think this actually needs to, why do we think we need to stimulate the market and actually impose or, try and impose this new radical approach and create sort of step change? Well, we're going to graph a couple of graphics here. So the one on the left is going to illustrate a price performance graph for the microsatellite domain. And at the top end, you have kind of typically expensive one-offs. So these are your traditional kind of satellites that have been developed for a specific purpose, maybe a big kind of Earth observation, so like a Earth imaging satellite, or something for doing forward communication systems. It was back in the mid-80s, a company called Surrey Satellite Technology Limited, which some of you may have heard of, basically created the small satellite market through developing performance satellites which make use of commercial off-the-shelf components and processes. And this did drop the price point of entry to market, and this was really revolutionary at the time. And this has basically paved the way for a lot of the small satellite constellations, sort of things like OneWeb. So OneWeb is looking at putting kind of satellite broadband and making that kind of a global service. And what these kind of companies have done to help kind of reduce their costs further is take a production line approach. So, they have a satellite which is for a specific purpose, and they can basically production line the manufacturing and the testing. And this allows you to get some savings with economies of scale. But the key thing to note is they are generally engineered for a specific application. They're bespoke to that need. There has been further revolutions in the small sat market. So some of you may have heard of CubeSats, and these are born out of academia. So they developed in the late 90s, so 1999. And effectively, they were, conceived to provide students a cost-effective way to sort of learn how to develop space missions. I think the first launch was in 2003, and since then, there's been a massive surge in the deployment and development of CubeSats commercially. So for those of you who aren't familiar, a CubeSat is comprised of what they call units. So it's basically a volumetric constraint, and you can have a satellite anywhere between 1 and 24 units. And a unit is about, if you imagine like a Rubik's Cube, about 10 centimeters by 10 centimeters by 10 centimeters, that's kind of the volume that you can then grow within. So most of them end up about shoebox size. And so companies like Planet Labs are making heavy use of this CubeSat capability, and they're using it to provide global imaging services. the kind of uptake of CubeSats really has improved accessibility to space, but it inherently, that platform type inherently has limitations. You can't outrun physics. We haven't quite figured out how to do that yet. So you've got a limited size, if you imagine kind of a shoebox size, and you have to pack everything into that. Whereas if you see some of the kind of small satellites, they're kind of more washing machine size. You've got quite a disparity in terms of scale. So this smaller size means, you can't fit certain payloads into the satellites. They just physically don't fit in the box. Also, sometimes you find you have limited attitude and orbital control. So that's how well you can kind of point your satellite, but again, because of their smaller size and how much kit you can get inside them. And also limited redundancy. You're limited on space. You don't have room to perhaps replicate some of the key units or some of the modules, which would allow you to, if you have failures, be able to continue to service your mission. And so these kind of factors can really impact reliability and the mission lifetime. So we believe there's a need to increase performance, but limit the price point to fulfill the outstanding market need. And this is where we believe our open source satellite will fit, and this is where it's deemed to sit. So it's intended to be a platform which can accommodate basically a whole multitude of different payloads that may have traditionally needed to go onto one of those larger, more expensive platforms, but at a price point that is down nearer to that of a CubeSat. So what is the open source satellite program? So we're going to embrace the open source principle, and our goal is to develop a 25 to 250 kilo class open source microsatellite platform. And the open source part is essentially we want to make that design available to everybody to use as a foundation for new systems. So it's got some key characteristics that we're hoping to hit. It needs to be performant, it needs to be capable, and it needs to be modular. And we need to be able to tailor the design. So you need to better kind of do reconfigurations and upgrades. So for example, being able to change the software that's installed, those kinds of things. And it also needs to be able to operate with multiple ground station networks. So for those of you who aren't in the space industry, there are a whole plethora of companies that offer ground station interconnectivity. So it's effectively how you talk to your satellite from the ground to space. And so what we want to be able to do is not be constrained to one single user, better maximize your options in your interoperability. And as I say, we're going to look at using commercial off-the-shelf parts, processors, and tools, and that will help bring that price point down. And as I say, one of the key points, and hence why it's the open source satellite program, is the design will be available to everybody. And this is really important, and to a lot of people in the satellite industry, actually a really counterintuitive approach to adopt, but it's one we think is important. And this is kind of the radical step change that we're talking about. And ultimately, going through this route, kind of having a modular, easily tailorable design, we really want to help reduce the amount of non-recurring engineering that's incurred when you nominally pick up a satellite mission, and you need to change the application, and so that's what we're looking to kind of help mitigate and again help reduce that price point. We don't just want to look at generating the platform. Another key tenet for us is the development and nurturing of an open source community that's able to use and contribute to and support the open source satellite program. And this community is really important because we could make the best thing ever, the best thing since sliced bread. But if no one is engaged, knows about it, thinks it's a good thing, no one's going to use it. So we want to develop that community. So, people come along with us, they see that it's a good thing, they get their points of view in, we actually generate something that is fit for purpose. And then also we get the benefit of being able to work with a wider pool of people. Working in kind of an open source way means you're not constrained by only, working with people from the space industry. You can get people from automotive, from kind of transport, and so on and so forth. And that we feel will really help us stimulate and generate new innovative ideas that may not have been seen previously. And we're hoping that providing the platform information via the open source route will allow it to become, much like CubeSats have, become the de facto standard for a microsatellite platform. And so that's our goal and our aim. So this takes us back to, okay, we've talked about what we want to do, and now it's like, well, how are we doing this? How are we tackling this problem? And as I sort of mentioned, we want to be able to be used for a wide range of different applications. And so the solution we're devising has to be able to address many different needs. And so we really want to be able to explore the context within which the open source satellite platform will be used and the types of missions that it might be used for. We want to be open source, and we want to be able to take input from others from a variety of different domains. And this is across different stages and of the developments. You don't have to be in it, time zero. You could come in somewhere along the development. And so to be able to foster that and be able to accommodate that, we need to be able to develop the solution in a logical and accessible way and have things which are easy for people to engage with. We don't want to give them a big tome and say, read these 3,000 pages before you can even get into the project. And I think these things really promote the use of systems thinking and model-based system engineering, rather than kind of a reliance on maybe some more traditional approaches. And so what we're going to talk about now in this next section of the presentation is specifically how systems thinking and model-based system engineering have actually been used within the program so far. Now, the initial goal was to explore the problem space within which the open source satellite would reside and actually understand some of the concerns of the different stakeholders. So we got together a team, got a bunch of engineers together who had extensive experience in the design, manufacture and operation of satellites. And they were briefed on the top level goals, which we covered previously, the development of a platform that can be used to satisfy a wide range of applications and leads to an open source solution. And then so we had that briefing, we got given a blank whiteboard, a set of colored pens and a direction, to actively challenge but it's always been done this way. And this is an engineer. It's a really exciting place to start. I'm not used to, maybe others you are more fortunate, but in my experience, it's very rare to be given total free rein and actually, look for a solution that isn't bound by things that have happened previously, or you've got to include this widget because we spent however much money to develop it, so we now have to use it on everything. There was no preferred suppliers, there was no preferred parts. It was truly here's a blank piece of paper, have at it, see what the best solution is. And that was really, really exciting. But it was about this point we actually hit our first stumbling block. It's actually really quite tricky, or at least I found, to try and do a clean sheet design without letting kind of what so previous experience and knowledge and the like, constrain the exploring of the problem. I think it's probably partly down to the team that we had, all very technically focused, lots of good engineering experience. And so we tended to sort of disappear down into the weeds of a possible solution rather than actually, taking that step back and looking at the problem holistically. So we therefore, to make sure we did the actual requisite work so that, the program was actually developed from a solid baseline, we developed a structured approach to the way we were going to undertake our discussions to make sure we covered all the areas. We didn't get excited and disappear off down rabbit holes, and we had something that actually, provided a good starting point, a good baseline. So the flowchart that you can see on the slide now was developed, and it was intended to provide a mechanism to align people on the intent of each stage of the problem exploration and help set some context for the team. Now, we deliberately started the flow at the customer application. So this is what the customer wants to achieve. This then really drives the needs of the other stakeholders based upon the application. But those needs and the fact that we have different stakeholders really sort of highlights that we actually have to spend a good portion of time looking at those stakeholders and make sure we take it from a top-down approach. There's indicates there's a number of viewpoints that we need to consider in order to be able to look at it holistically. It's not just what the customer wants that drives the solution, but it's actually those other perspectives, for example, regulatory bodies, or actually the folk who've got to put the system together, the manufacturers, their perspective and needs are also important in this case. And this really gave to us, okay, we need to do some serious effort on our context modeling. So once we'd established the needs, we then, the flow then took us through, okay, we can look at the functions. So what functions does the system need to have to be able to, satisfy the needs? And then we had a system of recursively decomposing these functions into what we were calling features, which would then effectively be able to be realized by a single physical component. So this flow was put together as a collective, and it provided a helpful step to kind of help transition the team from kind of traditional engineering into more kind of systems thinking and model-based approach. And another kind of thought behind generating this flow was to form part of the material that we could share with the wider open source satellite community. You know, as I've said, one of our aims was to develop a community, and we're aware that people might join over various points of the life cycle. So we want to make it very clear what the journey is that we've taken, because as system engineers, it's all about taking people on that journey so they can, you know, reach the conclusions that you do. And, you know, hoping by doing it in this way, people can see then where some of the artifacts that have been developed actually sit in and kind of see where they can get involved. Now, please don't worry about Ben. I read everything on this slide. There will be some zoom-ins in a moment. It's just to illustrate a point. But during the development of the flow on the previous slide, it became really apparent that although, you know, we're a team with all technical backgrounds, all have some grounding in the space industry, we still had some disparities about kind of some of the terminology that we were using. And it became really apparent, well, hey, if we're like a co-located team with fairly similar backgrounds and we're having problems here, if we want to engage with others or, you know, share it as part of this community, you know, that problem's going to be present no matter where we go, you know, and it's something that we need to solve. So in order to be able to tackle this, you know, tackle the potential for ambiguity and, you know, continue the development of a collective shared mental model, which, you know, we'd started to kind of get the founding for when looking at the approach we wanted to take, we decided actually, do you know what, it's worth taking the time to develop an ontology. So this figure is the complete ontology as it currently stands. And I say, I'm aware that this is an eye test, so you guys really won't be able to see this, but I've tried to take a few say zooms in here so you can see a bit more of the detail. So this is just an extract of what was on the previous slide. So for example, it shows how elements are defined as part of the approach that we covered on the previous slide, and how these perhaps relate with, you know, things in the wider some of the wider concepts within the ontology. We also show the relationship between the customer and the application and some of the different types of customer that we could have. Now, the ontology is a living artifact. And because you know, on day zero, I mean, this is like if someone asked you to write the dictionary, you wouldn't get all the words in on the first day, and as time goes on, you would, you know, discover more and add them in, and that's very much like the approach we've taken with this ontology. It's unlikely, you know, on day zero we would have found all of the concepts and relationships and terms that we needed to have. But one of the takeaways I think I definitely took from developing the ontology with the team is, yes, the ontology is a really useful artifact, you know, and it's really nice to point people at it and let them kind of see how terms and things knit together. But actually, some of the really useful part was actually coming out of the collective discussion that we had in creating it. You've heard me say this already about mental models, but it really did help the team kind of come together and, you know, have those discussions and see where things aligned and they didn't. And so we kind of, you know, really started to develop like a good collective mental model that we could then take forward into the work that we were going to, you know, do down the line. It also, I think, you know, has helped, you know, mitigate some of the assumptions and miscommunications that could have happened down the line. And another nice feature of it is, you know, when we talk to others and when we kind of bring other people in, or we, you know, develop our thinking a bit further, it actually also gives us a bit of a sanity checker, because what we can do is look at whether kind of concepts or things that we're trying to introduce into our context or into our modeling, whether they already fit within something that's already understood. If it's not there, you know, allow us to capture it. Or if it's already there, maybe, you know, we can check the terminology and the naming, because it might be actually that we're using kind of two different names for the same thing. And hopefully, you know, it will allow us to kind of get away from that and end up with a true kind of dictionary of terms for what we are, and relationships for what we're doing as part of the program. So normally at this stage on a traditional program, we'd be given or we would work with the customer to develop a requirement set. But with the nature of the open source satellite program, there aren't any custom requirements. In fact, the customers and the context within which they would want to operate is actually unknown. Therefore, kind of the document-centric approach that the most of the team were used to, we know where you have issued requirements and your concept of operations document, isn't actually where you would start from. And so in order to help overcome these unknowns and kind of do a bit more exploratory work, we started to look to introduce some model-based system engineering approaches to help facilitate exploring the problem and who the stakeholders are and what it was they needed. So the figure on this slide shows an extract of the original context diagram that was derived. And the intention of putting the context diagram together was to identify stakeholders and other interactions so that we could put the open source satellite platform into the appropriate context. Now, one thing it should be noted is that this diagram in this form was actually not the original mechanism for recording or generating this information. For some of the team, this has really been their first foray into using MBSE approaches. And one of the things that those of us who had kind of done a bit of MBSE before was we were cognizant that we didn't want to disrupt kind of the way people think and that creativity by kind of trying to introduce notations and techniques and things people weren't familiar with, because we didn't want to stifle actually what we wanted to do, which was this big kind of problem exploration and allow people to think in the way that's natural to them. So what we did is the diagram is actually a formal record of what was discussed in those brainstorming sessions, and so that's how we created that. We've actually done a bit more development. So this was, I think, what was presented in the paper. Between writing the paper and this presentation, a bit more work had been done. So I think some of the system boundaries had changed, as you can see in this slightly less neat zoomed in version of the context diagram. So I think now that the changes where the payload and the ground segment have both now moved into the system of interest rather than sitting outside in the wider system of interest. And this change was made not because any of the kind of high level aims or goals of the program had changed, but due to the kind of ongoing work we've been doing about looking at sort of the different stakeholders, their views, and the degree of interaction and control we were likely to have over those specific elements. A bit more work had also been undertaken between authoring the paper and giving this presentation at ASEC. What I've got on this slide here is an extract from the pig in the middle diagram that we constructed. And this was constructed based upon the context diagram that you saw on the preceding slide. So the context diagram identified the stakeholders and systems who had an interest in the open source satellite and the level of influence there was, between us and them and so on and so forth. The pig in the middle diagram shows the specific interests between the system and the stakeholder. So we've got on here a regulatory body. So a regulatory body, as the name suggests, their interest in the system is making sure you actually conform to regulations. We've also got on here a malicious third party. So they have an interest in the system, not one that we particularly want, but they do have an interest in the system, as they might want to disrupt or exploit the system in some way. So these were kind of useful to help us kind of identify why people are interested and why we have to care about them. So considering this context has really helped identify the perspectives and make sure the solution is fit for purpose, and looking at perspectives other than those of just the customer. So which has been really interesting. And so developing the interests of the stakeholders along with the potential applications actually will allow us to develop the needs that the system needs to fulfill. So this is just to sort of show a bit of, I guess, ballooning of scale. So through the context exploration work, it's been established there are a multitude of different perspectives beyond just the customer that we need to consider, when looking at what the needs of the system are. One of the primary goals of the system is to be suitable for many different mission types. So in effect, we want to take the platform, and for those, and apologies, I should have explained this earlier, the platform is one portion of a satellite. You tend to have a platform and a payload. And the platform, as much as it pains me to say it, because I'm a platform engineer, is the boring bit that people aren't really interested in, because it's the payload that makes you all your money. The platform is the bit that gets you there, points you in the right direction, sends the data down to the ground, so on and so forth. And so the aim is, in effect, in a very simplistic way, you pop off one payload and you pop another payload on, and that's the amount of reconfiguration that has to happen. And that's part of the charm of this configurable generic platform. And so we need to be suitable for many different mission types, which means you've got to think about your stakeholders against all the different mission types, because normally you're designing for one set of stakeholders against one mission. And as you can see here, it quite rapidly becomes quite a long list of people. And just illustrates just quite how many perspectives that we need to look at. And we started generating this list, and we rapidly realized, we need to put some kind of mechanisms in place to try and bound this work and actually also promote consistency. So if different engineers are looking at the different perspectives, that you end up with material that you can compare and you can assess against each other. And so what we decided to do was look at what we're calling a generic application as our starting point before we looked at the specifics. So it's believed that some parts of the system will not change regardless of the desired application. So the system was initially assessed independently of the actual application. And then this forms our baseline. And then we look at the specific applications to see what actually changes. So I'm just going to run through the flow of that now. So we start with our generic baseline that's been developed, and we compare it to a specific application, which gives us a modified baseline. And then we compare this baseline against another application, and then that should hopefully let us identify if we have any conflicts. Conflict management is an interesting one. It really depends on what the conflict is, the level of impact on the system, and how much control or influence the system has on the requirements that are actually in conflict. And this also helps with facilitating trades too, with regards to what we actually implement. Though, and I will say, we are walking before we run. So although the intent is ultimately the open source satellite will be able to service a whole multitude of different applications, it might be, that the first generation that we produce can't service every conceivable application type, just due to considerations such as funding. And unfortunately, we do have to pay for it along the line somewhere, available technology, or actually, if we have actually direct conflicts between the needs from different applications, so we'll have to pick which is the one that we're going to service with this particular version. By providing a baseline, which we can use as a template, it felt that this means we could do like apples and apples comparisons, because everything would follow the same format. And so this really helps as well, we felt, with kind of getting people involved, because you can give, people different work, but within the same kind of bounded things. When it comes back, it should be directly comparable, promotes common language, and also makes the results more shareable because they're all in the same format. So once you understand one, you should be able to understand all of them. So the figure on this slide shows some of the generic material that we've generated. I appreciate some of it's a little bit awkward to see, but we'll go through and we'll blow up various aspects of it as I'm going through and doing my descriptions. So what we've got here is an activity diagram. And there are a number of activities that stay the same regardless of what kind of space application you're trying to service. Every satellite, regardless of its type, needs the individual subsystems to go through some kind of qualification to prove that they're fit to fly. You won't get on a launch vehicle without some of these qualification results, and they need to be integrated, and then you need to do some kind of system level qualification. So that's a standard set of things that have to happen. And similarly, all satellites you've put in space, we haven't quite worked out yet, how to fabricate satellites in space. So, they all have to go onto a launch vehicle, survive launch, and you have to be able to integrate them. They have to survive launch, and the satellites need to know when they're actually in space and when they should start operating. Quite typically, satellites are actually launched unpowered. So they need to know at what point they've separated from the launch vehicle, and then they're in the space environment. And we've also got to consider end-of-life operations. Wanting to be a responsible space user, all satellites should have some kind of end-of-life related operations, to take them out of orbit and to get them out of, that congested area. It's the piece in the middle where the satellite goes through its commissioning activities and actually undertakes its operations, where the various applications might generate different needs, which actually then, go back and may conflict with kind of what we're looking to do, and that's where we really got to concentrate our effort. So at the point of this presentation, this is where we'd got to. So the process that we were working through was establishing the needs, and we were generating a generic set of needs against each stakeholder for a non-specific application. And then this would then give us a template to take forward to look at refining those needs against specific applications. The needs will be explored using use cases, and the intent is for them to be hierarchical. So meaning that all the use cases on a single diagram will be kept to a similar level of abstraction. And being mindful that we need to kind of make the information logical, accessible and understandable by a wider community, we will try and keep the level of information on each of the diagrams to a point that is actually comprehensible. So not like some of the other ones I presented earlier. And we also want to keep performing regular sanity check-in. That's key to us. So we want to be able to check whether the associations we've made between use cases and stakeholders feel right, and whether there's any gaps that we need to resolve. We also need to, once we've explored both generic and specific applications, we're hoping this will really help us hone in on where we need to be putting the most effort, and the team's energies to really kind of get into the details. So what I want to talk now about some of the things that we found about the way that we've captured the information and what worked well for us and perhaps what didn't. So generally, most of the material, especially the early material, was generated in like workshop style sessions, making use of whiteboards, sort of as per the image on the screen there. I think that's actually working image from our ontology. And we found kind of working in this way has been the most conducive method for stimulating discussions. And I know I'm guilty of this. If I sit with a tool, I get a little bit distracted trying to make everything look pretty, which kind of disrupts that flow of thought. So kind of working in a way that's deliberately not pretty, and on whiteboards or whatever, really kind of helps you just, get that information out. It's a lot more dynamic. The initial workshops, as I alluded to previously, we deliberately held them in a notation agnostic way, because we didn't want it just to be the preserve of the few of us who were who had done some MBSE before. We wanted to open up. We wanted to maximize participation. We didn't want people to be intimidated by the shapes and the way we were representing things. We wanted people to be able to contribute. So that was definitely key for us, but it's been really neat to use more formal notation to capture the data, because as you may have seen, you end up generating a lot of volume of data, and as that volume of data is increased, as well as kind of the complexities, and what's key for us is recording those interdependencies, you becomes very hard to do that on a whiteboard, and we also want to be able to share the information, and so that really started to push us towards needing to use a formal tool to capture the artifacts that we wanted to be able to present and share with people. Now, I admit this is partly my bias, due to the familiarity and the biasing of some of the engineers like myself who are working on the problem. SysML has predominantly been used to capture what the outcome of our discussions and working sessions. Other options were considered. I know it's not the only option out there, but basically that we felt the SysML as a notation and also the associated tool choices gave us the flexibility we wanted to be able to capture the data that's required. So here's just a little snippet of some SysML notation that we used. I think this is again our ontology. In terms of tool choices, Enterprise Architect is the tool that's currently been selected to create our model repository. I'm well aware, I've talked a lot about open source, and Enterprise Architect is not an open source tool, but kind of on reflection and kind of exploring a few different options, it allowed us to replicate and represent most of the data required, including the bits and pieces that we haven't done via SysML, so things like the context diagram. It does have a neat feature that you can actually export files as HTML, and you can use that with a free viewer. So that does improve accessibility to those without the tool. Other tools such as Capella were considered, and although Capella doesn't use SML, the notation is sort of similar, but the tool from what we wanted to do was a little bit more limiting, and we wanted to be able to get sort of all those interconnections in, especially to some of the kind of more whiteboardy sessions, and so Enterprise Architect really kind of helped with that. Another really nice feature of Enterprise Architect is this ability to make navigatable kind of splash screens. So you can see here, you know, someone can kind of click through and get to the information that they want. And so this kind of helps people who are less familiar, or also, you know, when we want to share as a HTML kind of format, you know, allows them to be able to engage with it in a much more straightforward way. So one of the areas that we were finding tricky was how to undertake model-based reviews. So the team that I work with are really used to be given a stack of, you know, paper documents to review, and you know, the approach and process for doing that, you know, is really well ingrained. But undertaking model-based reviews is a new activity, and you know, there's a few things we had to consider. You know, we have a team that isn't all geographically co-located. They may have not all been as involved in generating the artifacts which are under review, and they may have very limited model-based system engineering experience. And you know, and sometimes it's not just what's on the screen, but you also want to be able to look at those linkages and you know, interdependencies that sit there in some of the metadata. So it's, you know, getting those views and things right, so you can actually get someone to review the material in the way that you need them to. Another factor that needs to be considered, as I've sort of talked about previously, was actually there's a lot of value in those shared discussions that we had when generating some of the material. And at times it almost feels like that almost has more value than the actual artifact that you come out with at the end. And this is, I think, a lot to do with the fact that it does a lot in terms of aligning thinking and teasing out problems and issues, and like I say, taking everyone on that same journey. So some consideration has gone into actually how we capture that so that other people can kind of catch up on that if they weren't there at the time. So that's something else that we consider is really quite important, and so this is something we're still refining. So just as a bit of a summary of where we are, so the open source satellite program is still in its early stages, as is the use of system engineering and model-based system engineering approaches within it. At this point of the program, the intention's really been to kind of align the project team, undertake some holistic explorations of the problem space, and now take those forward to really get into like the needs of what the system needs to do, so we can make sure it has the correct functionality. I think it's fair to say, and I don't think I'm talking out of turn, not only my team are here to disagree with me, but I do think the techniques that we've been using have been really quite useful in allowing us to kind of take the whole team on the same journey, and, you know, say it again, you know, get that truly shared mental model, so, you know, we're all on the same kind of wavelength and path. You know, we're happy that we've put together this structured approach to how we're going to explore our problem space, and, you know, that we feel gives us the means to be able to compare directly what we're generating and how, you know, what information comes in. And we feel it puts us in a good place to be able to highlight the conflicts between different applications and, you know, really develop a solution that, you know, satisfies the widest possible realistic set of goals. I think that's the key one, you know, and that's something we have to keep one eye on. We can't fix everything. What is the realistic set we can do? We have had some challenges, as I've discussed, you know, transitioning the team from more traditional kind of engineering approaches across to this kind of more model-based approach. Touch wood, so far, these challenges, you know, haven't been too complicated, but I think that's in part because the team who are more familiar with MBSE have been very aware that they're, you know, imparting something new, so have, you know, been making considerations and trying to work in a way that, you know, does bring people along. And so I think kind of doing that hybrid approach of not imposing notations and, you know, forms and things early on, and letting that creativity, you know, come out and be shared before kind of putting, you know, those more formal things behind it has really helped, because people can see then how their ideas have been realized rather than getting lost in the notation. I'm aware this is probably not the totality of our challenges. You know, there will be more. There always is in engineering. such as, getting that real robust process for undertaking the model-based reviews is one on the horizon, and actually, needing to be able to share all this in a useful way with a wider community is also something we need to overcome. But I will admit, it's nice having a bit of a mixed team where there's different levels of experience in this area, because those with less experience really do keep those of us with slightly more experience honest, because they stop you from going too far off without explaining why you've done something or why something looks like it does. So the next steps in terms of the programme are to conclude looking at the generic baseline and then be able to do the comparisons to the specific applications and identify the conflicts and come up with those needs so we can start looking at the features and the physical composition. We also need to continue and further develop sharing the material with the wider community. So that's actual aspects of the model, as running explanatory sessions to explain why we've got to where we've got to, and actually run maybe some workshops to get some more information in. And it's very much our intention to continue using model-based system engineering and system engineering techniques to support these activities. So I think that brings me to the end of the slideshow. So I just want to say thank you very much for your attention.
Okay, well, thanks very much, Vicky. That was an excellent presentation. As I remember it being the first time, it's really good to see such a diverse set of stakeholders sort of working together as well on a single project, and I think that's really I think that's an achievement within itself. So really good presentation. We got some questions coming through now, so we've got about 10 minutes left. So if you do have any questions, please just type them into the chat. So the first question we've got is from Martin Chandler. So it said, did you consider doing some additional modeling of a generic service, i.e. not just the system, so service-based, I guess, rather than pure systems-based, offered to run the satellite to support the mission operations and applications? So I guess it sort of support services, support service-based applications.
Yeah, no, and that's definitely it's definitely one of the interesting challenges, because we admittedly started with a platform because we're all platform people, so that that's where we felt comfortable. But yes, we do, and we have done some modeling of some of those support services that sit around, because they can actually have quite a big impact upon how your system then works, particularly around kind of operations, because as you can all probably imagine, the more money you pay, the more service you get. The less money you pay, the less. So it starts to have quite an impact on kind of how autonomous you need to be, kind of how much you need to be able to cope for, without kind of utilizing some of these ancillary services. And so it's been interesting, and it's still an interesting challenge, in kind of finding that balance between what is, ultimately, do you have, having a satellite you can push the button on and it just goes, and you just occasionally it throws you some data and you never have to talk to it, to kind of having to really engage with some of these other services. So it's been an interesting it's something we have been looking at, and we've engaged with some outside parties, because we're not experts in some of those areas, to get sort of information. The other interesting challenge is also not just looking at the now, but looking at the future, because there's a lot of companies coming through who are offering new services that didn't, perhaps, especially at the time of doing this presentation, didn't exist. So the way that those services are also supplied is changing. So it's definitely an area that we say we started some modeling on. We do need to continue, and we will need to keep an eye on that as the kind of that external environment changes. So I don't know if that answers the question, but.
Yep. Thanks for that, Vicky. We've got a couple more questions. So first of all, Paul Adams, who could have possibly been one of your lecturers at Cranfield. Who knows if it's the same one? First of all, great presentation, Vicky. I'm guessing by the gushing, maybe he was. Given 4 years have passed since this presentation, have you found that you've needed to revisit the context modelling as the context has changed over time? If so, has this been straightforward to identify impacts or update your systems modelling in Spark CA, that being the tool? Okay.
Yeah, so we definitely have. I mean, the environment has changed over time. There are when we started this, and it's something we've been looking at, is the competition was different, and kind of what was provided as standard on some other platforms has changed. And so that's kind of had us go back and look at kind of what we perhaps had deemed in or out of context back at the beginning. So we have had to go around and look at that, particularly around some of the applications. So there were some applications initially we sort of said, oh, that's probably out of scope, and we've had to go back and go, oh, actually, maybe we do need to look at that in scope, and how we bound it against the work that we've done. There's a lot of information. I mean, we've tried to set it up in a way. I think it's one of these things, isn't it? When you set something up and you do it, and then you go back and you go like, oh, I wish I'd just done X, Y, Z. So we definitely have learned some lessons about how we set up especially some of those. I think some of that kind of that metadata and some of those attributes, to make those in a format that we could do a bit more with. So there has been a bit of work. How straightforward it's been depends on what member of the team you talk to, because various members of the team like Enterprise Architect more than others. But it's definitely, we have been able to use the framework that we set up to be able to kind of do those iterations. I think the real proof will be in the pudding of we have a kind of a generational and a product line view on where the open source satellite will go, and I think that's where we'll really find, when we want to do some of those iterations, where we've left some holes, and truly how easy it is to go back and push the data forward.
Okay, thanks, Vicky. Another very thorough answer. The next question we got is from Ian Raper. Traditionally, satellite design involves a lot of iteration between the payload and platform design. To what extent do you expect expect a generic platform to be able to satisfy diverse payload needs?
Yes, that's a really good question, and the biggest challenge there has been drawing a suitable boundary where we can satisfy a good percentage of what we feel are payload applications and the payloads, without designing for every possible permutation. So the idea of the open source satellite platform is to try and make kind of interfaces and things as kind of using kind of traditional, but like as open as possible kind of interfaces, so maybe kind of looking at using kind of buses and things, rather than something like a lot of direct point-to-point, which you might get on some bespoke designed satellites. And also we are designing knowing that we're going to have to be modular enough to allow people to kind of add bolt-ons. So like, if you have a satellite, our platform will generate X amount of power. If you came along with a big synthetic aperture radar payload, which sinks a lot of power, we know we would need to be able to grow our power system. And the idea is the units that we are developing have the scalability to be able to accommodate those different sizes. And it might be, especially for some of the early gens, we have to look at kind of putting payload interface boxes in that can actually kind of soak up some of those differences, as we refine really what that get that payload interface kind of nailed.
Okay, great. And then we probably got time for another quick couple of questions. Now, the next two questions are actually quite closely related. So I'm going to ask you both, Vicky, and then just over to you to answer. So out of curiosity, have any of your customers adopted any systems thinking / MBSE approaches? And have you managed to integrate any of these across organizational boundaries? So the whole systems thinking MBSE with your customers. And a similar one, but looking more internally, what was the decision-making process in using the systems thinking diagrams and MBSE, considering a lot of your team wasn't too experienced in this area? So again, I think two closely related questions then. So
yep, sure. So it's mixed in terms of sort of clients, customers, predominantly on a client side. So we do have clients who have used MBSE approaches. It's something it's something that there are some aspects, some elements in the space industry do use them and some don't. And it has been conversations I've been having with so like the UK sort of bodies and stuff about how we perhaps look to use MBSE and systems thinking kind of more, because a lot of especially in some of the big organizations, it's born out of kind of big institutional traditional kind of approaches. So it's something that we've been sort of discussing with people, but it's not something we've tangibly yet kind of worked with another entity on. To answer that first question. The second question about kind of what was the decision-making process, what we were really aware of is we didn't want to just, it would be really easy for our team, because of the experience they have, to sit and just design a satellite. But what we wouldn't have done is looked at actually how that fits within that kind of that broader piece, and how it would fit in 5 years, and so on and so forth. And so that was really the genesis for going, actually, we really need to kind of do that systems thinking and perhaps challenge people to think in a different way, because what we're trying to do is something quite different because of the number of needs and applications we're trying to service. So that was really the genesis for it. Also, my boss was interested in us trying something different, and this was a good vehicle to do that. And so it's fingers crossed it's working well. And that was kind of and we have a team now who are more familiar with it. And so that's, it's been and it's been nice to start with something that everyone's kind of, from our team, it's almost started at the same point, so everyone has learned together. So it's worked well.
Okay, Vicky, that's fab. I'm sure we could keep going for another hour just on the questions alone. Really good presentation. Thoroughly enjoyed it the second time round as well. It's also really nice to see somebody in a senior position who's still so passionate and enthusiastic about their work. And I think that comes across very much in the presentation. So no, really good presentation, Vicky. Really pleased that you'd agree to come and do it. It has been recorded, so it is going to be available for anybody to download from the Encoder UK website. I'd like to thank, on top of Vicky, all the participants who came along and hopefully enjoyed Vicky's presentation, and all the people that have asked the questions. And of course, thanks to Encoder UK for hosting the whole event.